Okay, so we are going to continue from where we stopped previously. So previously we stopped at question number 25. So we are going to continue with 26. So 26 sounds like this. Tin foil iodide can be prepared by boiling 0.04 mole of the tin under reflux with 0.03 mole of iodine dissolved in 50 centimeter cube tetrachloromethane. Okay, so orange crystal of the product are obtained by filtering the hot reaction mix and then cooling on the filtrate. Which of the following will indicate that the reaction has already complete? So in here, you must try your best to understand that we have initially 0.04 mole of tin react with 0.03 mole of the iodine. So which one is the limitant? So from here, we can clearly see that iodine is the limitant in here. Okay. So how do we know that if the reaction is complete? That means iodine is completely disappear. Okay, so you should no more see the purple vapor because you are going to hit at 77 degrees Celsius. So eventually some of the purple vapor will be released at this point. Okay, so we should have not seen any more purple vapor because iodine in here acts as a limitant in here. Okay, so the best answer for 26 is D. Then we are going to go to question number 27. The following reports appear in the newspaper. Drums of bromines broke open after a vehicle crash on the motorway. Traffic was diverted as purple gas of bromine drifted on the road as it is denser than air, causing irritations to drivers' eyes. Firemen spread water over the scene of the accident, dissolving bromine and washing it away. So which one is wrong about the report in here? So in here, the strangest part in here is the purple gaseous bromine. So bromine is not purple for information. Bromine is brown. Okay, so that is for question number 27. So the best answer in here is D. Which of the following do not decolorize bromine? So in here, in another word, which one do not react with bromine? So chlorine mixed well with the bromine does not decolorize. Okay. So Fe2 plus oxidized to Fe3 plus when added to bromine. So B is correct. Okay. And then C2H4 undergoes bromination when mixed with bromine. So you form a dibromo, you form a dibromo compound according to the equation C2H4. When you react with the bromine, you form a dibromo. This one, CH2Br, CH2Br. And then this one is a phenol. So phenol, when react with bromine, okay, this one you learn in organic chemistry. Sorry for that. Because we are still in semester 2, you not yet learn about semester 3. So it will decolorize the bromine water to give this one. Okay. So the best answer that describe all this is A. Okay. Okay. So that is for question number 28. Then we move into question number 29. The propellant used in the solid rocket booster of a space shuttle is a mix of aluminium and compound X. So compound X contains chlorine in the oxidation state +7. Which of the following could be X? So you have to calculate which one has the oxidation state of +7. So in here, NCl3, the Cl is -1. NHCl4, the oxidation state is also -1. N2H5, oxidation state is also -1. It is NH4Cl O4 that is the oxidation state is +7. So that is for question number 29. Then number 30, which of the following compound when react with chlorine to give two products in which chlorine has different oxidation number? So we are looking from something that can undergoes disproportionation. So the one that can react with to disproportionate is B, sodium hydroxide. So if you want to know further what is the reaction of ethene, so ethene when react with the chlorine will form a dichloro ethane. Okay, so it forms CH2Cl and CH2Cl. So the oxidation state in here are both -1, and then potassium hydroxide, sodium hydroxide, as I show you. For potassium iodide, if you react with the chlorine, so you form KCl plus I2. So in here, we form from 0 to become -1 because chlorine is an oxidizing agent. So in here, sulfuric acid does not react with the chlorine. Okay. So the best answer in here would be B. Okay, then we go for number 31. Chlorine gas is widely used to treat contaminated water. Which species present in the water where chlorine gas has been added is responsible for killing bacteria? So the particles that is responsible for killing bacteria is the OCl minus. So the best answer in here is D. Okay, then number 32, hydrogen chloride and hydrogen iodide gas has different thermal stability. The difference is due to the difference in energy of some covalent bonds that are involved in the decomposition. Which role identifies the most stable of the two compounds and give the correct explanation? So in this case, hydrogen chloride is more stable because it has a shorter bond length. So therefore, the best answer that describe all of this is B. Okay. Okay, so that is for number 32. Then we go to 33. The solid sodium chloride and solid sodium iodide both react with concentrated sulfuric acid at room temperature. So with NaCl, the products are NaH, SO4, and HCl. And with NaI, the product are NaHSO4, Hi, I2, SO2, H2O, and H2S. Which best explain for the differences in here? So A, chloride ion will displace iodine solution, which is not happen. In this case, because they are separated, so they are not reacted together. So A is wrong. So hydrogen chloride is more volatile than hydrogen iodide. It is also not the reason why it can react, because these are two separate things. And then iodide ions are better reducing agent than chloride ion. This is true because iodide ion can easily oxidize to become iodine because it is a better reducing agent in here. And sulfuric acid able to act as a dehydrating. It is not dehydrating agent. Sulfuric acid act as an oxidizing agent. Okay. So in this case, therefore the best answer that describe what is you see in here is C. Okay, then we go for 34. An excess of chlorine gas CO2 is passed through 60 centimeter cube of cold aqua 0.1 mole per decimeter cube sodium hydroxide. In a separate experiment, excess chlorine gas is passed through 60 centimeter cube of hot NaOH until no further reaction. So how many much more of sodium chloride will be produced by the reaction of hot NaOH and cold NaOH? So in here you have to write both equations in order for you to find out. So the mole of the NaOH in here will be 0.1 times 60 over 600, so you get 0.006 mole. So in cold NaOH, so Cl2 react with 2 NaOH to give NaOCl plus NaCl plus H2O, whereas in warm chlorine NaOH, so 3 Cl2 plus 6 NaOH give NaClO3 plus 5 NaOH. So in the cold NaOH, stoichiometrically, because 2 NaOH is to 1 NaCl, so therefore the mole of the NaCl is half of the 0.06, you get 0.03. And then in warm of the NaOH, say 6 NaClOH give 5 NaCl, so therefore the mole of NaCl becomes 0.05. So the difference of the NaOH is 0.05 minus 0.03, you get 0.02 here. Okay, so the best answer in here is A. So I hope that you can understand the calculations that is shown in here. Okay. Okay, so that is for question number 34. Okay, then we go for question number 35. Two students P and Q were asked to draw a bar chart to represent how some of the properties of the halogen and their compound differ in magnitude. Their diagram is shown below. The bar chart shows the trends not the exact value. Okay, so which student has drawn the bar chart which shows the correct trends in here? Okay, so in terms of solubility for silver iodide, so it's supposedly to be the other way around. So AgCl is the most soluble, AgI is the most insoluble. And then in terms of delta H, the delta H become less and less negative, which is true. Okay, so it's correct. So in another word, this is incorrect. Okay, and this one is a correct trend. So in here, the best answer is Q, correct. Okay, so that is for question number 35. Then immediately we go to question number 36. Aqueous silver nitrate is added to the solution of potassium iodide and aqueous ammonia is then added. What will we observe? So in here, AgNO3 will first react with NaI to give AgI plus NaNO3, but AgI is insoluble in excess ammonia. So you see a yellow precipitate that does not dissolve in addition of aqueous ammonia. 37. X represent the atom of chlorine, bromine, iodine, which explain for the variation in the volatility going down to the group 17. So a volatility are supposedly decreased when going down to this one. So when we explain volatility, we have to use the molecular structure where all of them are simple covalent molecule held by weak van der Waals forces. So as going down to the group, van der Waals forces increase. So that is why it is less volatile. So when it is less volatile, so that is why the intermolecular forces become stronger. So the best answer that describe all of this in here is A. Okay, so that is for 37. So immediately we go to 38. Bromine is extracted from seawater in the final stage. The process of the two redox reaction takes place in here. We have bromine plus SO2 plus 2H2O give 2HBr plus H2SO4. Then the 2HBr further react with the Cl2 to form bromine gas and also HCl. Okay, so which row is correct in here? So you have to identify which one is, since bromine can displace by can be reduced by SO2. That means SO2 is a stronger that means Br2 is a stronger oxidizing agent than SO2. Okay, so bromine can react. So, but then fluorine are able to oxidize HBr to become Br2. Therefore, chlorine is a stronger oxidizing agent than bromine. So the lowest one will be sulfur dioxide, followed by bromine, then chlorine. So we are looking from the strongest to the weakest. So it should be the other way around. Okay, so the best answer that describes all this is B. Okay, 39. Which statement about halogen is correct? So iodine cannot behave as oxidizing agent. Yes, can. Iodine can still behave as an oxidizing agent, even though it is weak. Volatility of the element increased from chlorine to iodine because of the increase in molecular size, which is true. Okay, so the volatility decreased, not increased, decreased. Okay. So when equimolar of the mixture of chlorine and hydrogen is exploded, only one product is formed, which is true because only HCl is formed. And when concentrated sulfuric acid is added to solid sodium hydromide, hydrogen sulfide is the one product. No, you form sulfur dioxide. So the best answer in here is C. And then finally, for the objective question number 40, chlorine react with both hot and cold sodium hydroxide to form chlorine-containing product. So cold sodium hydroxide forms sodium chlorate X, and hot sodium hydroxide form sodium chlorate Y. So X and Y are oxidation number. So which is correct? Equation is correct in here. So you have to understand what is the oxidation state of the chlorine in both reactions. So in cold, Cl2 plus 2NaOH give NaOCl plus NaCl. So the oxidation state of the Cl in NaOCl is +1. And then in the warm is 3Cl2 plus 6H2 NaOH give NaClO3 plus 5NaCl plus 3H2O. So here Y is 5, X is 1, so the difference will be 4. Okay, so the best answer in here will be C. Okay, so with that, that is for the 40 objective question in section A that I would like to discuss with you today. So we are going to continue with the structural questions. Okay, so let's have a look together at the questions. Okay, so question number 1 sounds like this. A bleaching liquid can be prepared by reacting chlorine with aqueous solution of potassium hydroxide under room temperature pressure. 1. Write a balanced ionic equations for the reaction to take place. So in here you have to write ionic equations. The question already demands. So we must write ionic. So sorry for that. I accidentally write as one should be OCl minus Cl. Sorry for that. Okay, so in here, what is the correct balanced ionic equation? So this is the correct balanced ionic equations. Okay, number 2, state the changes in oxidation state of the chlorine in here. So 0 to +1 and 0 to -1. So you have to mention both of them, only then you can get both marks in here. Okay. And number 3, state the active ingredient in the bleaching liquid that is formed. So the active ingredient that makes the bleaching active is OCl minus. Okay. Okay, so that is for number 1A, and then 1B. The making of photochromic glass is based on black and white photography concept. What is the added substance in the photochromic glass? So in here you add silver bromide, GBr. So using suitable equation, explain the observation when photochromic glass is exposed to sunlight. So when you expose to sunlight, you are exposed to ultraviolet. So what happens when to extra to ultraviolet? So the silver bromide will decompose to become silver and the bromine. Okay, so according to the equation, 2Ag Br give 2Ag plus Br2. So this is what happens when you expose the silver bromide under sunlight. So it undergoes decomposition reactions. Okay. Okay, so with that, that is for question number 1. Immediately we go to question number 2. Diaphragm cell used in commercial electrolytic production of chlorine and sodium hydroxide shown below. So this is the diaphragm cell. So number 1, the ionic equation for the reaction at anode is 2Cl minus gives Cl2 plus 2E minus. Right ionic equation occur at cathode. So the cathode will be 2H2O plus 2E minus give 2H minus plus H2. Okay. Number 2, based on the experiment in A1, explain the both formation of sodium hydroxide as a side product. So you are reacting Na from the NaCl, react with the OH minus from the product of the electrolysis from the cathode to form a NaOH here. Number 3, why is the porous asbestos diaphragm used in this cell? So the porous is to allow the cation indeed to attract to the cathode. So this is a permeable ion permeable diaphragm used in here, where it only allows the positive ion to get across to the cathode compartment in here, and that is why you form the sodium hydroxide. Then a chemical substance Q when chlorine and sodium hydroxide react, and write a balance equation for the reaction. So you write any balance equation that is react with the chlorine and the sodium hydroxide. So the equation in here, the name is either sodium chloride or sodium hypochlorite. So you must write name, cannot write formula name. That balance equation, only then you can write the formula. Okay, so that is for 2A. Now we have 2B. Chlorine produced through diaphragm cell is then dissolved in water. Explain in which equation what happened when chlorine dissolved in water. Because chlorine is a very high, undergoes disproportionation inside water, according to this equation. So that is why we expected that chlorine in here will be undergoing disproportionations inside here. Okay, so that is for number 2. So immediately we go to number 3, the direct outline method of obtaining bromine from sea salt water, which contain mainly sodium chloride and some sodium bromide. So this is the seawater. When added to chlorine, it has yellow color, which is then separated by ether, you form yellow solution. So you put inside potassium hydroxide solution, co-dilute. Okay, so those which are not reacted are recycled by the ether and come back as a intense yellow color in here. Okay. So after that, when you mix with this whole aqueous potassium hydroxide, you see 2 layers. Okay, so these 2 layers is due to the formation of this organic compound and also the non-polar compound and covalent polar solvent. Okay, so when you are seeing 2 layers, later you have to filter the layer 2 lah. Okay, and then you form aqueous solution, and then you put white paste, and then you warm an acid distill, you form a red film which condense to red liquid from formula. So this is what happens when you try to mix the halogen out from the seawater. Okay, suggest what causes the intense yellow color produced in A and next used as relevant inner value in the data book. Okay, so that is for A. So A here you see an intense yellow color is caused by the moving water according to the half equation. Cl2 plus 2 minus give 2Cl minus, that is for reduction. Then for oxidation, 2Br minus give Br2 plus 2 minus. So that is why you observe an instant yellow color, because chlorine in aqueous solution is a pale white, pale yellow. Okay, so that is for number 3A. Then we go for 3B. Organic solvent ether is immiscible in water. Explain why the yellow liquid is soluble in either B or and the salt that's not in here. So you must know by yourself that bromine is a non-polar molecule, so you dissolve light, dissolve light. Okay. Okay. So that is the 2 marks in here, and then 3 mark write the equation for C and D. So this is what happened in C and D. Okay, so this is what the equations written for here. Okay, then we go for question number 4. So chlorine dissolves sparingly in water and the solution form can be used as bleach. Write equation for the reaction between chlorine and water. So you have Cl2 plus H2O give HCl plus H2Cl. Identify the compound in the solution that has a bleaching properties. The active ingredient in here is HOCl. Okay. Then number 3, calculate the volume of 0.100 mole centimeter cube of sodium hydroxide solution needed to neutralize solution containing 1.00 times 10 power negative 3 mole of the chlorine. So in here you have to understand, since one chlorine produces 2 acid, one is HCl, another one is HOCl. So that is why you require 2 mole of the sodium hydroxide. So you use mole equals MV over 1000, or V equals to 2.00 times 10 power negative 3 times 1000 over 0.01, you get 200 centimeter cube. Okay, so that is how you are going to solve for question number 4. So I hope that you understand on how to calculate this part. Okay, B. Compound stated in A2 will lose its bleaching property under certain conditions. State the condition that causes the bleaching property to be lost. So if you expose it under ultraviolet, so write the equation for the reaction. So 2HOCl give 2HCl plus O2 and use equation in A1, B2. Write overall equation when chlorinated with water under the condition mentioned. So this is the overall equation. So 2Cl2 plus 2H2O give 4HCl plus O2 in here. Okay. So that is for number 4. Okay, so we continue straight away to number 5. So describe the appearances of the bromine. So bromine appear as a brown, reddish brown liquid. Okay. And explain why bromine has a higher boiling point than chlorine. So both of them are simple covalent molecule held by weak van der Waals forces. However, bromine has a greater molecular mass, molecular size. Therefore, the intermolecular forces inside the bromine is stronger. Okay. So if possible, you also might want to write down what causes the intermolecular forces to be stronger. So it is due to weak van der Waals, the strength of the weak van der Waals forces is greater inside the bromine here. Okay, so try to write this. Okay, see, write equation for the following reaction. Phosphorus burning in excess chlorine, so you form PCl5. The product from the 1 react with water, so PCl5 react with 4H2O, you form H3PO4 plus 5HCl. Aqueous sodium chloride is being added to aqueous silver nitrate, so you form AgCl plus NaNO3. And then aqueous ammonia is added to the mixture of 3, so you form AgCl plus 2NH3 to give the complex of AgNH3 2Cl. Okay. So that will be all for the reactions involving chlorine and bromine. Okay, so with that, that is for question number 5. So immediately we move to question number 6. The gaseous hydrogen halide HCl, HBr, Hi may be prepared by reacting the corresponding sodium salt with anhydrous phosphoric acid H3PO4. When the sodium halide NaX was used, the following reaction occurred and the sample of gaseous HX collected in the gas jar. So 3NaX plus H3PO4 from Na3PO4 plus HX. A hot glass rod was placed in the sample of HX. Immediately, a red-orange color was observed. So in here, the keyword lies with the red-orange color is observed. So these are trying to tell you that it is bromine. Okay, so identify NaX and explain your answer. So the NaX in here is sodium bromide. So why? Because red-orange gas is bromine is released, so that indicates that the bromine is the reddish solution. B, name the gas other than HX will be formed if concentrated sulfuric acid were used with NaX instead of phosphoric acid. So write the equation for the reaction occur. So you form two gases. One is bromine gas, then another one will be sulfur dioxide. Okay, so according to the equation, 2H3L plus H2SO4 give Bl2 plus SO2 plus 2H2O. But the more accurate one is SO2 because Bl2 may be liquid at some points. Okay, so the best one is still writing SO2 in here. Okay, number C, suggest why phosphoric acid is used rather than concentrated sulfuric acid is used to make the sample of HX that corresponds to the sodium salt. Explain your answer. So in here, you have to know why we don't use sulfuric acid. Is because sulfuric acid is a stronger oxidizing agent. So therefore, it will not oxidize the X minus to become X2. Okay, so this is the reason why we use a H3PO4, because H3PO4 is a weaker oxidizing agent compared to the H2SO4. Okay, so it won't oxidize the Br minus to become Br2. But H2SO4, yes, it is a stronger oxidizing agent compared to bromine. So it is able to oxidize the bromide ion to become bromine. Okay, okay. So according to the equations. Okay, so with that, that is how we are going to answer for question number 6. Okay, immediately we go to question number 7. The element in the group 17, the halogen and their compounds show many similarities and trends in their properties. So table below shows some of the properties inside there. So A, explain the meaning, the terms of enthalpy change of atomization. So atomization is the heat absorbed when one more of gaseous atom is formed with an element under standard conditions. So one mark here, very straightforward. Okay, then B, for fluorine and chlorine, enthalpy change of atomization are half the value of bond, but for bromine and iodine, the enthalpy change of atomization are much more than the half of this value of bond energy. Suggests a difference for this. So this is due to F2 is less endothermic than Cl2 since the repulsion of the lone pair electron inside the fluorine caused the bond strength to be weakened. Okay, so that is why when this happened, okay, so the bromine is more endothermic than iodine because bromine has a smaller atomic radius than iodine. Therefore, the bond strength between the Br is greater than the I. So that is why it is much more compared to the fluorine here. Okay. So you have to know on the reason behind why is it that the bond energy inside the fluorine is lower than expected. Okay, even though fluorine has a smaller size compared to chlorine here. Okay. Okay, so that is for A2. B1, explain the trend of boiling point in the hydrogen halide HCl, HBr, Hi. So specifically, they ask for HCl, HBr, Hi. So first of all, you must explain their structure. All of them are simple covalent molecule hold by weak van der Waals forces. As the molecular mass or molecular size increase, so the strength of the weak van der Waals forces also increase. So try to describe as fully as you can whenever you are answering such questions in here. And then B2, suggest why the hydrogen halide HF does not follow the trend in the boiling point shown by HCl, HBr, Hi. So because HF is held by strong hydrogen bond, so the F is more electronegative than Cl, Br, and I. So therefore, HF bond is harder to dissociate compared to HCl, HBr, and Hi here. So you must be very good in explaining what makes the HF hard to dissociate. Okay. Okay. So with that, that is for question number 7. Immediately we move to question number 8. The mineral fluorspar contain calcium fluoride CaF2, which is found in many properties similar to that of calcium halide. Draw the Lewis diagram for the calcium fluoride. So it is an ionic bond. So you must draw the structure of the ionic bond, CaF2 plus F2 minus. B. Calcium fluoride react with concentrated sulfuric acid to give a gaseous hydrogen fluoride. Write a balance equation for the reaction. So in here, when you write this equation, you can only substitute one one hydrogen only from the sulfuric acid. So you form CaF2 plus H2SO4 gives CaHSO4 plus HF. Number C, when reacted with concentrated sulfuric acid, calcium bromide give bromine, whereas calcium chloride give hydrogen chloride. Using suitable equation, why is this so? Because bromine is a weaker oxidizing agent than H2SO4, while chlorine is a stronger oxidizing agent than H2SO4. Or if you can simply just write oxidizing strength increase from Br2 to H2SO4 to Cl2, automatically this will give you 2 marks in here because you are describing once and for all. Okay, so therefore the two equations involved in here is NaBr plus H2SO4 give NaHSO4 plus HBr, then 2HBr plus H2SO4 give Br2 plus SO2 plus 2H2O. Then D, deduce the expected observation if calcium bromide is to replace with calcium iodide. So you're expected to form a purple vapor or black spot release. Okay. Okay, so I guess that is all for the structure questions. So in our next video, I'm going to continue with the essay questions for chapter 6 in here. Okay, so I hope that you can understand of what my explanation goes so far, and I'll see you in my next video. Okay, see you all.